All right, continuing on with what we talked about yesterday with respect to graphs of sines and cosine. As we go through these things, as I've said numerous times, and noodles of times in this classroom, when we start initially going through this, you tend to be a little bit and a little bit confusing in regards to it. Okay, but as we continue to go through problems and you start hitting some of the cues in it, it starts to slow down for you. It starts to slow down for you. Now, that's not saying that it's going to be snap your fingers and everything's going to be all perfect, and I'm going to wave the magic wand over top of you and say, kababa, shishkumba, and poof, you know how to do it. You're still going to have to do some work. Okay? But you need to continue to push yourself through that and not throw your hands up and say, this is too tough. Okay? It's not too tough. You can be able to manage yourself through this. So continue to push through it. We're going to go through the other two problems that we had for today, or on the back of the notes today. And once again, as we go through this, hopefully the cues that we will continue to do will continue to kick into your brain and make this a lot easier for you. Just going over what we talked about yesterday, when we talked about a sine curve, we start on the prime axis. We have a cosine curve, we're going to start at peaks and valleys. Okay, we have a vertical phase shift, we have a horizontal phase shift. Vertical phase shifts, the constants being out front. Horizontal phase shift is a value that's being subtracted. Okay, so we have addition here, we have minus and negative there. It's a value that's being subtracted. Amplitude is the value out in front of the sine and cosine. The period's calculated by 360 divided by b. Okay, the cues that we've gone through yesterday. Okay, when we find all of our information. Okay, we find vertical phase shift, horizontal phase shift, amplitude, period. First thing we always take a look at is the vertical phase shift. Second thing is we have a theta start value, horizontal phase shift, along with our trig functions. Okay, then we use the period, and then we use the amplitude to be able to get our graph down. Okay, and we went through two different graphs yesterday. We were finishing this one up. Did we finish this one up? Okay. We have y equals -1 plus 2 cosine half theta plus 90. We found the amplitude, period, vertical, horizontal phase shift. Okay, we have the first thing we take a look at when dealing with the problem is the vertical phase shift and the prime axis. So we threw in our prime axis here at the value of -1. The second thing we take a look at is we take a look at our start value and our trig function. Our trig function was a cosine, so we start at either peaks and valleys. Okay, our theta start value is -90. So at -90, we have to start at a peak or a valley. When it's a positive cosine, that will be a peak. So when we take a look at the peak, the amplitude is the value that gives us our peak value. So from our prime axis, which is at -1, we have to go to a peak of 2. We have to go up 2 from our prime axis. So if we start at -1, we go up 2, we go to a value of 1. The third thing we take a look at is where we end up at. Okay, if I start at -90, the period is the number of degrees in a cycle. The cycle is a portion of the graph to another portion of the graph where the graph starts to repeat itself. So if I start at -90, if I go 720 degrees to the right or to the left, it does not matter. I will be at the exact same y value. So the easiest thing is just take your horizontal phase shift and add the period to it. That'll give us our value that we end up at. So if we're at -90, add your 720 to it, we're at 630. If we're at 630, we'll be at our peak value again. If we're here at a peak, we have to be at peak here. Play our games of halves, halfway between -90 and 630, add them together, divide by 2, we get 270. Okay, so we have a peak here with our cosine curve. We're going to scream all the way down low and then back up again. So we're going to be at a valley. So if we take a look at a valley, we go down to from our theta, our prime axis here. Okay, so if we go up to for our peaks, we have to go down to get to our valley. So we're down at a value of -3. Okay, the next is our games of halves between -90 and 270. Between a peak and a valley or valley and a peak, we're going to cross the prime axis. So halfway between -90 and 270, okay, once again, add together, add the two numbers together, divide by 2. Take the -90, 270, add them together, then divide that value, then hit enter. then just divide by 2. Now we'll get you your second value. Between a peak and a valley, you will cross the prime axis. So your negative 90, between negative 90 and 270, will cross the prime axis. And then between 270 and 630, the exact same thing. I'm going from a valley to a peak. So halfway between a valley and a peak, I will be crossing the prime axis. So play your games of halves twice. Add the two numbers together. You add your two numbers together, hit enter. Then you could just hit divide by 2. And now we'll get your halfway point. Once again, KYC, know your calculator. So those 2 points would be where you cross the prime axis. Laura, what's those 2 theta values? $450. Okay, at 90 and 450. Once again, take 270 plus 630. Okay, take 270 plus 630. Hit your enter button. Okay, you get a value. You don't have to recopy that number. Just hit divide by 2. So you hit your division button. It will pull your answer down for you and divide by 2. My last thing is the y-intercept. My y-intercept is at 0.4. If I look at 0.4, here's my point of 0.4. So if I look at my graph, it would be my cosine curve. What happens when we have a negative in there now? All this does, it changes the direction of the graph. It's not going to affect the amplitude, period, vertical, horizontal phase shift. Okay, so I want you to calculate your amplitude, the period, the vertical, the horizontal phase shift, and the y-intercept. And check your answer with somebody around you. Okay, by inspection, look at your equation. Yes? Nope, absolute value of your A value. Okay, your amplitude is always the absolute value of your A value. Sign out. Find the amplitude, the period, vertical, horizontal phase shift. And that's a good question by Nolan. Amplitude is always just the absolute value of A. I have a negative 4 there. Just take the absolute value of that, so you just have 4. Okay, check your answers. Make sure you check your answers with somebody around you. Yep. Yep. 3 times negative 30, and then close your parenthesis out. So you put 0 in for theta. You have sine of 3 times negative 30. Then close your parenthesis out.
Because you either multiply it or divide through hours. So you have to go back down. So there's no way to do this.
All right, let's take a look. Amplitude period, Grant, what do you have? Amplitude in the period. 4 and 120, taking 360 divided by 3, we get a value of 120 degrees. Here's your A value, here's your B value. Absolute value of A is your amplitude. Vertical horizontal phase shift, Odessa, what do you have? Okay, the value, what is the value that's being subtracted from theta here for your horizontal phase shift? What's being subtracted at? 30 is being subtracted. So your horizontal phase shift should be a value of 30. Okay, once again, your y-intercept, you're putting in 0 for theta. You're putting in 0 for theta, so you can clickety-clack into your calculator, -3 minus 4 sine, if you want to, 3 times -30. Or if you want to do some mental math, -90. Does not matter. Y-intercept, Sydney, what do you get? Type in -3 minus 4 sine of 3 times -30. Where's your calculator at? Well, it looks like you need to get a new one. Y-intercept, because if you don't have that, you're going to have a tough time doing any of these problems. Brendan, what do you have? 1, value of 1. So you have -3 minus 4 sine 3 times -30, or -90. We good with that? Yes, no, maybe so? Good. All right. So take a look at the graph now. Okay, I take a look at my graph. My amplitude is 4. My amplitude is 4, and my vertical phase shift is -3. So I have a vertical phase shift of -3, which is going to push my graph downward. So I need to be a little bit more bottom heavy here with my graph, because I need to make sure I can go down 3 and an amplitude of 4. So I'm going to be a little bit more bottom heavy. Once again, that's the first thing you take a look at. You take a look at your vertical phase shift and the amplitude. That will tell you, do I need to be top heavy or bottom heavy? I need to be a little bit more down here because I have more negative stuff. So looking at my spacing here, 3. I need to make sure I need to stretch down to at least 7. Now, if I take a look at my theta axis, the period's 120, so it's not very big. Vertical phase shift of 30, so I don't have to stretch out or make my 90s really small. I can make my 90s a little bit bigger as we go along. 90, 180, 270, 360. I want to -90 here. I probably could have went a little bit bigger. But we're okay. Once I get my 90s down, I can divvy those into thirds now. So I'm going to divvy these into thirds. It doesn't have to be exact, but try to get close. Yeah, once again, as you experience more and more of these and get more and more of the graphs down, you'll get better at it. Okay, you will get better. You just have to trust that you'll get better. Just keep on trying to plug yourself through it. First thing we draw in, what's the first thing we draw in? We've done it now twice now. Vertical phase shift. Okay, so the first thing we draw in. Okay, look at your vertical phase shift. So go down to -3 and draw in your prime axis. Once again, these cues are going to be the same. Second thing, where do we start with our theta value? Our horizontal phase shift and our trig function. Okay, we have because you have two values you have to worry about. You have to worry about where you start on the theta axis and where you start y with respect to the y. Okay, so you have two values. You have an ordered pair. You have two values you have to worry about. Okay, so we have our theta start, which is our horizontal phase shift. And then we have the trig function, sine or cosine. Rachel, are we starting on the prime axis or at peaks and valleys? Prime axis. So on the prime axis at 30, we have our first point. Third thing, where do we end up at? I start at 30. The period tells us how many degrees we have to go until we were at the exact same spot again. So if I start at 30, every 120 degrees, I will be at the exact same y value. So if I start at 30, at what theta measure will we be at on the prime axis again, Brandon? 150. So 150 will be on the prime axis again. Now we start playing our games of halves. Halfway between 30 and 150. Add them together. Hit enter. Divide by 2. Where are we at, Bryce? 90 degrees. Now we have to remember what we're dealing with the sine curve. Sine curve, we start on the prime axis. We can climb, and then we can drop, and then we climb back up again. So if I hit my prime axis here, hit my prime axis here at 90 degrees, what's going to be our y value going to be? Where we're going to be at again? Matea, what do you think? Okay, sine curve, I'm going to either go up and down, or am I going to go down and back up? It doesn't matter. Okay? Between 30 and 150 at 90, what's going to be our y value? Where our graph's going to be? Nah, not going to be going up. Well, where will we be at? At -3, still on the prime axis. Okay, the sine curve is going to go up, dive down, and back up again, or it's going to go down, go up, and then back down. We're going to cross the prime axis again. So if I have 2 on the prime axis, I'm going to cross the prime axis again here at the value of 90. Because I have to go up, down, back up, or down, up, back down. Okay, it's going to be a sine curve. Okay, it's going to be a wave. Okay, this is where the negatives come in. I have to play halfway between 30 and 90. Halfway between 30 and 90. Add them together, divide by 2. Or hopefully you can just see the spacing that we have there. I have 30, I have 90. Hopefully we can see that 60. Yeah, use our noggin a little bit. Okay, but this is where our negative comes in. Our negative, since typically we will go sine curve, climbs the hill, then we scream, and then back up again. That's a typical sine curve. But since we have a negative there, we have SpongeBob opposite day. So we're going to go down first. Okay, we have to go an amplitude of 4. Down to -7. Because we have to get this amplitude of a value of 4. Okay, we have to go from our prime axis, we have to go down 4. We're at -3 on the prime axis, we have to go down 4, so it's going to take us to -7. Halfway between 90 and 150. Hopefully you can count up again. I got 30, 60, 90, 120, 150. Okay, hopefully we can see that's 120. If not, add 90 plus 150 together. It's 240. Divide by 2, we get 120. Okay, the question is, what's the y value? Well, we go down first and then we go back up. What's the y value have to be? What's our y value have to be here? Sorry, what? The value of 1, that's correct. Because we have to go up. We have to go up 4. Okay, we have to go up our value of 4 to get to my peak. Okay, once again, your amplitude comes from your prime axis. Our y-intercept is a value of 1. So it takes me back up to here again. So if we look at our graph, should be a nice flow in our graph. I'm going to change this problem. I'm going to change that problem. Y equals 1 minus 3 cosine 1/3 theta plus 90. So go ahead and change the problem. The theta plus 90 in there. Determine the amplitude, the period, the vertical, horizontal phase shift, and the y-intercept. Okay, look at the values. Amplitude period, Braylon, what do you get? 3 and 1080. That's correct. Vertical, horizontal phase shift. Allie, what do you get?
1 and -90.
That's correct. And y-intercept. What do we come up with the y-intercept? Negative what?
2.
-2? Go with that? We good? No? Negative 1.6? Is that better? All right. Should have 1 minus 3 cosine of 90 divided by 3 or 30. So we have cosine of 30. Okay, let's take a look at a graph of this. Okay, take a look here. My amplitude of 3, vertical phase shift of 1. So I need to be just a little top heavy, not much. But I take a look at this. This is the problem I run into is I got the big period here, 1080. Okay, so I need to really be able to space this out. So I can count out by 90s if I want, but I'm going to make my 90s really small. Or I can count out by 180s. It does not matter. I can count out by 180s and then cut the 180s in half. So if I go, let's see, here's negative 180, 180, 360, 540, 720, 900, and 1080. And then I can divvy those into halves. Yeah, that's a way of possibly doing that. Or I could count out by 90s. It would be another way of doing it. Just go 90, 180, 270, 360. That would be fine too. Once again, it's something as you, I think I see more ease in regards to what you're doing right now. You're not looking up and copying exactly what I have down each and every time now, which is good. That's the progression that you have in regards to the learning process and the patience with the learning process is you're starting to become a little bit more comfortable in what we're doing, and you're not having to write down exactly what I have written down up there. Okay, you're starting to be able to do that a little bit more on your own. Okay, first thing we draw in, go ahead, draw it in. Vertical phase shift, draw on your prime axis. Second thing, where do your theta start value? What's your theta start value? That's your horizontal phase shift. Your trig function will tell you if you're at the peaks and valleys or on the prime axis. Madison, are we at peaks and valleys or prime axis here? Peaks and valleys, because it's a cosine curve. So then we take a look, do we do the peak or do we do the valley? Well, the negative will tell us if we do a peak or valley. If it's a positive, that's a peak. If it's a negative, that's going to be a valley. So at negative 90, we have to go to a valley. Okay, our valley, once again, is determined by the amplitude. So from our prime axis, at negative 90 at our prime axis, we have to go to a valley. So if I'm at negative 1, or if I'm at positive 1 with my prime axis, My amplitude is 3. I have to go down 3. So if I'm at -1, that would take us to what y value? Laura? -2. So it's going to take us down to -2. Because I have to go, once again, an amplitude of 3. Third thing we take a look at is the period. It tells us where we're going to be at the exact same spot. So if we're at -90, 1080 away, we're going to be at the exact same spot. So once again, what the easiest way, if you struggle with this a little bit, just take the horizontal phase shift where you start at, add the period to it. Take the -90, add 1080 to it. That will tell us what theta value you're going to be at. And we'll be at the exact same spot. Which is where, Paige? 990. So at 990, we'll be at the exact same spot, which is at 2. Games of halves, halfway between -90 and 90. Add them together. Divide it by 2. Between any two valleys, we'll be at a peak. So we have to go to the peak. So that'd be what, 450? 450, we're at a peak. The peak is from the prime axis, so we have to go up from the prime axis 3 positions. So at 450, we'll be at a peak, which is 1, 2, 3, up at 4. Between a peak and a valley, we'll be on the prime axis. So -90 to 450, take the halfway point. And 450 to 990, or 990, take the halfway point, we'll be on the prime axis. So it should be at 180, I think. 180 is the first one. And the second one is where? 720 on the prime axis. If we take a look at our y-intercept, the -1.6, it should be a nice, I'm sorry, that's a bad spot. -1.6. Here's our -1.6. We should have a nice flow of our graph through those points. Once again, the Q's are going to be the same. What we're going to do tomorrow is we're going to take a look at graphs and we're going to determine the equation, but it's going to be the exact same Q's. Your homework is on Monday's assignment, page 53, problems 1 to 8. You have 8 graphs to do. Page 53, 1 to 8. We'll go over a graph tomorrow. We'll go into finding the equations of graphs. Finding the equation given the graph. We're just going to put the process in reverse tomorrow. Once again, it should be slowing down for you a little bit. Okay, it's still not going to be perfect, I get it, but it should be slowing down for you. It should be better for you now than it was yesterday at this time. Questions?